So today we're going to look at using our slope-intercept form to apply it to different situations. As you can see, we're going to do it using word problems. So what I'm going to do, I'm going to write right at the top here what our slope-intercept form is. Remember, it's y equals mx plus b. And we're going to kind of pull that apart to figure out how I can model a situation using that. So up here, my important parts, my rate of change, remember that's another word for slope. So that's my m. My initial value, think of that as our starting point. We talked about it being the starting point when we were graphing. And our starting point is always b. And then if you think way back to when we first started all this stuff, we talked about what a function is, what a relation is. And when we're talking about independent and dependent variables, remember my independent variables, my x, and my dependent variables, my y. So we have places for all of those in this equation. So let's take a look at a couple of these and see how they shake out. So this first one says a computer repair shop charges a $25 fee in addition to $40 per hour to service a computer. Write an equation to represent the total cost to service a computer. Identify your variables. So probably the easiest part of these problems is finding out what your m is. And the reason for that is this word per. Per is always going to indicate that that is your rate of change because it's happening as you increase your hours or decrease your hours, and it's something that's going to change there. So my $40 per hour, I'm going to say, is my rate of change or my slope. So that's a kind of easy way off the bat to get this rolling. Now my starting point, my initial value, is something that's not going to change for this. So if I read this problem, something that's not really changing is this $25 fee. Whether I'm going to a computer shop for 10 hours or 100 hours, there's always going to be a $25 fee in addition to my $40 per hour. So my initial fee, my initial value is 25 bucks. And my independent variable, let's kind of identify what those are. Something in a lot of these problems, what you're going to see, the thing that is changing, the thing that is dependent on the other one is always your y. And in this case, that's going to be my cost. So the amount of money that I have to spend to get my computer fixed. So my dependent variable in here is going to be cost. Which the only other thing that's left here, the thing that's my independent variable that's changing all the time that affects the cost, is my hours. So my actual equation here is y equals 40x plus 25. Because I'll just go through and we can go down and label what each of these things are. My rate of change is m, my initial value is b, and my independent and dependent are x and y. Let's try another one, and then you're going to do some on your own. So number 2 says an online photo printing shop charges 15 cents per print. Now when you see, right when you see that per, that should be an indication right away that you found your m. 15 cents, and we'll say per print. So that's my m. In addition to a $2.95 shipping charge. That $2.95 is going to be my initial value. Because think about, I don't know if you've ever ordered pictures before, if you've ordered something like this. That $2.95, they're saying that that is something that's added on to every order. It doesn't matter if I order 1,000 pictures or if I order 2 pictures. That's a value that's not going to change. So that's my initial value, or my b. So let's do the same thing that we did up top. We'll let x equal something, and then we'll let y equal something. And then it says we want to write an equation to model the total cost for printing pictures. Identify your variables. So again, think about, I think dependent's kind of the easier one to find, because you want to think about which one relies on another, which variable relies on another variable to change. So my 2 variables here are my number of prints and my total cost. Now my total cost is going to change based on how many prints I have. So that right there gives me that my cost is dependent. It's going to change based on the number of prints, which is my independent variable. So X is my number of prints, Y is my total cost, and then I can plug my stuff into my final equation. Y equals 0.15x plus 295. Now let's skip down to the next page because I want to show you how you can use these to solve a problem. Let's look at like number 5. So it says a truck rental company charges $19.95 to rent a truck plus 24 cents per mile driven. There's my per. Find the cost to rent a truck and drive 188 miles. So something else that you want to keep in mind, usually we said that when I've got a per, that's going to be my m. That's going to be my slope. Whatever that number is hanging out with, so like per what, per mile, that's always going to be your x, which we know is our independent variable. And then the other pieces I've got here, I've got a truck rental. The truck rental company charges $19.95 to rent the truck. So if you've ever moved and had to rent a truck, or know your parents had to rent a truck, the company charges you a flat fee in addition to an amount per mile. So this right here, this $19.95, that's my B. So if I put that equation together, y equals 0.24 x plus 1995. That's my equation that I'm starting with. And that's what we did on the first page. Now the second part, find the cost to rent the truck and drive 188 miles. You're going to use this equation now to solve. So the number they're giving me is 188. We already said right here that 188 miles were our independent variable, our x. So I'm just going to take this equation I made and plug it in. So I'll say y equals 0.24 times 188 plus 1995. And then I'm just going to solve that out. And what you're going to get is $65.07. So in order to rent that truck and drive 188 miles, it costs $65.07. So you guys are going to try the rest of these to try and get the hang of using the slope formula to actually solve some problems.